So I thought it would be useful to go through a problem with isotopic abundance that was a little bit different than the one that I gave earlier. So in this example, it reads that bromine has two natural isotopes, bromine 79 and bromine 81. Bromine's atomic mass on the table is 79.904 AMU, and the mass of bromine 81 is 80.9163 AMU and is 49.3% abundant. Calculate the mass and abundance of bromine 79. So the most useful thing is to sort of outline the form. So remind yourself that what is the general form of this equation? So we have mass times abundance. So mass of bromine 79 times abundance of bromine 79 plus the mass of bromine 81 times the abundance of bromine 81 equals the average atomic mass on the periodic table, which is 79.904 AMU. Okay, so the easiest thing to do is to find the other percentage. Because we only have two isotopes. So if they both add up to 100%, then 100% minus the one that we know will give us 50.69% for bromine 79. All right, so now I can put some numbers into the form of my equation. So I can say the abundance of bromine 79 is 0.5069 times the mass of bromine 79 plus the abundance of bromine 81, 0.4931 times the mass, which was 80.9163 AMU equals 79.904 AMU. So I end up with 0.5069 times the mass of bromine 79 plus 39.8998 AMU, and we're tracking at the fourth sig fig. Right, so sig figs still matter. Sig figs always matter, really. 79.904. Right, and we solve for the mass of bromine 79. So we get 0.5069 times the mass of 79 equals 40.00417. Tracking at that fourth sig fig. And basically I'm just stepwise going through the process of solving for the mass. So our mass of bromine 79 equals 40.00417 AMU divided by 0.5069. So the mass of bromine 79 will be 78.89 AMU and is 50.69% abundant. Okay, sig figs still matter. Yes, I recognize that most of our numbers in this problem have lots of decimal places, but we have to pay attention to sig figs. Okay, now The other important thing to recognize is that coming back up to our problem here, the mass on the table is 79.904. The masses of the individual isotopes should be close to that number. All right, this is a way to check your work on this type of problem. So our mass of bromine 81 is 80.9. It's very close to 79.9. And the number we've calculated for the other isotope is 78.9. Also very close to 79.9. Now, if I were to go through this problem and calculate the mass and figure out, and what I calculate is something like 40 AMU, something went wrong. Okay, because the masses of your individual isotopes should be close to the average atomic mass. Okay, so it's a way to sort of evaluate your work. If you get something that's far away from the average atomic mass, you've done something wrong, and you need to go back and check your work. All right, I'm going to go ahead and make this a short video and go ahead and stop here, because our next topic is very different from this, so I'm going to go ahead and make a separate video here. All right, enjoy.